Hey, ladies and gentlemen, and welcome to our very first notes of Unit 9. So this is Unit 9, Notes 1-1. So today we're going to be graphing inverse variation. So we're going to talk about what that is, why it's important, how we're going to use it, and all that, and we're also going to practice graphing it today. So let's take a look at this first. Let's just kind of figuring out what it is. So take a look at this graph right here. Okay, so we're talking about the gear ratio to the rate in miles per hour. Okay, so this is basically telling us how fast we pedal versus how fast we're going to go. So let's kind of just read through the sentence and we're going to just fill in some blanks here. The number of revolutions of pedals made when riding a bicycle at a constant speed varies inversely. That's hard to see. Varies inversely as the gear ratio of the bicycle. In other words, as the gear ratio decreases, okay, so as we turn our gear rate down, the revolutions per minute increases. So what inverse variation means is that when one goes down, the other goes up. Okay, so this is why shifting to a lower gear allows you to pedal with less difficulty. So when you're going up the hill, sometimes when you're riding a bike, you change the gear so that you don't have to pedal as hard because it's already hard enough going up the hill. So this is inversely related because the lower we've changed the gear, the higher we have to pedal, the more times we're going to pedal. So inverse variation is when one decreases, the other increases. So let's go ahead and you're going to write that down in the chart. So inverse variation, y varies inversely as x. There's some non-zero constant k such that xy is equal to k. So we're going to take our x coordinate and our y coordinate and we're going to multiply it to equal to k. So for most problems, we're going to have to find k to start off with. We have to find k in order to be able to do these kinds of problems. So let's take a look at number 1. So for number 1, it says the time it takes to travel a certain distance varies inversely as the rate at which you travel. Okay, so it makes sense. If we travel faster, we get there sooner. Less time traveling faster. They're inversely related. One is opposite than the other. The equation RT is equal to 2005 or 250 can be used to represent a person driving 250 miles. Complete the table and draw a graph of the relation. So this R right here is going to represent our X value. This Y right here is, or this T is going to represent our Y, and this 250 is going to be our K. We know that because of the XY is equal to K that we talked about on the previous page, except this time we're using RT. Okay, so we're going to go ahead and we're going to fill this out. So first of all, let's just remember the equation that we're using. So we have RT is equal to 250. So now what I'm going to do is I'm just going to plug in random values for R. These are what I'm going to plug in for R. So I have 5 times T is equal to 250. Divide both sides by 5. And I get that T is equal to 50. So when R is 5, T is 50. So now I'm going to go ahead and I'm going to plug in 10. So I have 10t is equal to 250. Divide both sides by 10, and I get that t is equal to 25. So this is good. They're inversely related. As this is getting larger, or this is getting larger, this is getting smaller. Okay, that means they're inversely related. This is what we want. So now we're going to go ahead and do 15. So then when I do that, I get 15t is equal to 250. Divide both sides by 15, and I get t is equal to 16.67. Okay, so that's going to go up under here, so 16.67. Okay, so I want you to go ahead, pause the video, fill in the rest of this chart for me by plugging in the values up there. Okay, go ahead and fill those in. Okay, so I filled in that chart for you. Hopefully you were able to kind of calculate it out on your own as well. And now we're going to go ahead and we're going to graph these points. Okay, notice that this is the same really as this one. They're just flip-flop. That's what's going to happen with inverse variation. Okay, sometimes they're going to flip-flop like that. So let's start by graphing this point. So we're going to go over 5. So R is this axis over here, or the x-axis, and this is our y-axis. So we're going over 5, and then we're going up 50. So over 5, up 50, that puts me at this point right there. Then over 10, up 25, that puts me at this point right here. Okay, then we're going to go over 15 and up 16.65. So I'm going to go up to 15 and just a little bit past it to represent that 16 right there. And then for 20, I'm going to go just a little past 10 to get that 12. Okay, it's hard to write on here. So next, for 25, we're going to go up to the 10. For 30, we're going to go up to the just below the 10 to represent 8. For 35, just below that. For 40, just below that. And then we're going to go ahead and level that out. Okay, so that right there is your final answer. So what you're going to notice is that we're not passing the y-axis here, and we're not passing the x-axis here. And the reason for that is that the 0 doesn't make sense. Traveling 0 miles per hour, you're not going to get anywhere. And traveling, you know, at a 0 distance isn't going to help you calculate your speed. So let's take a look at some straightforward graphing ones. So for this one, graph an inverse variation equation where y varies inversely as x when y equals 15 and x equals 6. So now we want to calculate that out. So what I'm going to do is I'm going to take those y and x values that I underlined and I'm going to multiply them together. Remember that xy is equal to k. So let's go ahead and actually let's write out what steps we're doing. So the first thing we're going to do is we're going to write the equation. So that's what I was working on right now. So the first thing we're going to do is write the equation. Okay, so then I'm going to take it, I'm going to multiply my x times my y and set that equal to my k. Remember we talked about how we have to know what our k is. Well, 6 times 15 is going to give us 90. So my equation then is xy is equal to 90. So this right here is what I'm going to be graphing eventually. Okay, so next, your second step is to pick x values. So we want to pick good x values, specifically x values that divide 90 evenly, because I don't like decimals, they're icky. I like nice numbers. So things that divide 90, let's take a look. So what I'm going to do is I'm going to do multiples of 3. So I'm going to have 0 in the center. I like 0 being my center. Well, 90 is even, so I am going to do -2 and +2. So this side is going to be negative numbers, and this side is going to be positive numbers. So here I'm going to have 3, 6, 9, and here I'm going to have -3, -6, and -9. So you'll notice it kind of makes a little mirror on either side. So next, our third part that we have to do is we have to find the y values. So now we're going to plug in those x values. So let's start with -9. So I'm going to do -9, y is equal to 90. So I plugged in -9 for x, and now I'm solving for y. So I divide -9 by both sides, and I get that y is equal to -10. So I find -9 up here, and I know y is equal to -10. So then this side is going to be my positive side. So if I divide by a +9, I'm going to have a +10. So this should be a mirror. Okay, so then I'm going to go ahead and I'm going to plug in -6y equal to 90 and solve it. Divide both sides by -6. Okay, so when we divide both sides by -6, then we're going to get y is equal to a -15. So again, we're going to be setting up that mirror on either side. So if this is -15, this is going to be positive. So right now, I want you to go and calculate out those values for me quickly. Pause the video. Now let's quickly talk about that 0 there. Okay, so what we're basically going to have is when we plug in 0 for x, we're going to get, 0y is equal to 90. So now I'm going to divide both sides by 0. Now in math, here's a huge no-no. You cannot divide by 0. So because you cannot divide by 0, this is undefined. So then this right here is undefined. So now we're going to go ahead and we're going to plot those points. Okay, so I'm going to go up by 3s on here. So we have to change the scale a little bit. So I'm going to go 3s here. And I'm going to go 10s up this way. So 20, 30, and so forth. So now I'm going to go ahead and plot those points. I'm going left 9, so -3, -6, -9, and up or down to -10, which would be right here. Okay, so go ahead and we're going to keep plotting those points. So then I'm going over -6 down 15, which if I'm going by 10s is about right here. About right here. then negative 3, negative 30 would be right about here, negative 2, negative 35. So what's going to happen is this is just going to curve down this side. Okay, so that's just going to curve down this side. Now looking over here, we're going to have the same thing, but the positive version. So 2 up to 35. 3 is at 30. 6 is at 15. 9 is at 10, and this is going to curve down this way. So if you look at it, it's like if there was an invisible line right here that these two kind of reversed over each other. It kind of looks like a mirror that way. Okay, so that's kind of what it should look like. Let's take a look at the next one. So first thing we're going to do is write that equation. So right now I'm going to take 12 times 4 and set it equal to my k. So 12 times 4 is equal to my k, and that's going to give me 48. So my k is equal to 48, which means the equation that I'm graphing is going to be x times y is equal to 48. So now we want to pick good values for 48. We're going to put our 0 in the center. Well, good values for 48, I'm going to use 2, 3, 4, 6. So I want good even numbers. You could have done all even numbers if you want. I just decided to throw 3 in there because I thought it would work well. So we're going to do negative 2. So we're going to do the same on the other side. Okay, so right now what I would like you to try and do is I want you to fill in this entire thing. Remember, 0 is going to be undefined, so go ahead and fill in that chart for me. So you're going to be plugging in values of x to get your y in the bottom of the chart. So pause the video and fill that in. Okay, so hopefully you did that on your own because it's good practice because you have to do it on your own for your homework. So here is the table. So I'm going to have this go by 2's, and I'm going to have my y-axis go by 5's. So if you change your scale of your axis, make sure you let Ms. Humbert know. You need to write it down so I know what scale you're using. So here, for this equation, my first point I'm going to plot is 2, 24. So I'm going over 2 up to 24, which is going to be about here. Then I'm going over 3 up to 16. So I'm going to just go just past 15. Right here. And then I'm going to go over 4 up to 12. So it's just past 10. So this isn't making a line. It's kind of making a slope, like a scoop kind of. And then 6 is going to go to 8, which is right here. So we're going to go just like this. So it kind of looks like an exponential equation. And then you're going to go ahead and you're going to graph the other side. So graph the other side for me. Okay, let's move on to the next one. So for this one, I'm going to have you try this entirely on your own. I'm going to get it set up for you. So we have 8 times 2 is equal to your k. So remember, your first step is to write the equation using what I just did here. Pick your x values, then do your y values. All right, let's take a look at this word problem. The owner of the superfast computer company has calculated the time t in hours it takes to build a particular model of a computer varies inversely. So we're going to use the same process. So it gives us the equation PT is equal to 12. So we can go ahead and use the fact that PT is equal to 12. We can skip the first step because our equation's already written. We can skip the second step because this is already done for us. So now all we have to do is fill in that chart. So here are your x values. Go ahead and fill in the chart for me. Here's a hint. So if we're taking 2, we're going to plug that in for P. P is the same as x. T is the same as y. So we're plugging in 2 for t and solving that for 12. So that first one is 6. So go ahead and fill in the rest of the chart for me. So if you notice, we do have some decimals on this one. So what I'm going to have you do is I'm going to have you get rid of this scale on here. We're just going to use it as if it was normal. 1 square is going to represent 1. So the first point, we're going over 2 and up 1, 2, 3, 4, 5, 6, and plotting that point. We're going over 1, 2, 3, 4, and up 1, 2, 3, and plotting that point. Or not. Come on. There we are. We're going over 6, up 2, and plotting that point. And then we're going over 8 and up 1.5, which is about here. And then we're going over 10 and up 1.2, which is just above 1. And then 12 itself is at 1. So we're sloping down. So on any of these, you don't want to be crossing the x or the y axis. Okay, so make sure you have your completed note sheet, all 3 sides. Bring it up front and show me, and then I will give you your homework for the day. Thanks for listening.